Well, then you're in the right place then to get started and learn all about computers. Hello. You're going to excuse me if I can't spell or say your name too correctly. But hello, everyone. Thank you for joining me. Good. I'm glad you want to know everything. There's a lot to learn, and I'm glad you have the enthusiasm to learn it. Good. You have a passion for computers. Yeah, there's a lot of, we're going to go over a lot of operating system concepts. And you're going to be learning a lot of it. Is going to be in the beginning just learning a lot of terminology. And when you learn the terminology, then you start being able then to read further, and that one explains how these things work. So we'll take a good fundamental look at the computer, the hardware, how it works, because the operating system is really what makes it work. And that's what we're going to learn. How does the operating system make, the computer work? So it'll be a very good introduction to all those concepts. And then later you'll get really familiar with one or two operating systems that you're going to use in your working environment. And sometimes in the workplace you'll have many different environments. So this course just kind of introduces you to all the different operating systems that are out there and how they just basically work the same, and that is to run your computer. Hello, everybody else. I know I'm kind of getting started earlier here. I do apologize. I was getting a little picture on the screen, but it wasn't coming through. But I'm just glad you're all coming in here. This is our first office hour or question and answer session and just beginning the course. So there you go. If you want to speak, I can put your microphones on as well. I don't know if you want to speak or just or text. Either way works fine. Oops. Again, welcome to IT241 operating system. Everybody can hear me okay? Good. Thank you. Well, we'll have the office hour and we'll run for 1 hour. I know it is the evening where you are. It's the morning where I am. And it's a cold morning here where I am. I'm in the Midwest, and it's below 0 wind chill factor, so it's very cold here. But I'm thankful that I'm inside. So again, welcome to the course, and hopefully, are you all familiar with Blackboard so you can get in and navigate okay? How many of you have taken Blackboard courses before? Or online courses, I should say. I'm assuming you have taken more online courses, yes? Yeah, I have one. I think you're going to be the spokesperson for the entire course here. But that's okay. So, again, this is the beginning of the course. So it's a matter of just reading the material, doing the assignments, and also posting the discussion. Now, the discussion is an area where you can collaborate with your classmates. You can also ask questions if you have any questions. It's a great area then, you know, in between office hours or where you can ask your questions for the entire class and or just even, you know, post some links maybe that you found that you liked or discuss something in the textbook that you read. There are a lot of videos for each chapter, each week, for you to view. And again, you will be having some assignments. You will be programming an assignment. We will be using Java. So how many of you, because I'm going to type as well as talk. How many of you know Java? Good, I'm glad to hear that. More and more of you. Good, you took a course, good. Or you're studying Java now. This will give you then a good practice with Java. So yeah, do review your Java because we will be using it in this course because we're going to be exploring different strategies and algorithms that operating systems use in order to honor the user's requests. We're going to look at how operating systems manage various aspects of the computer. And in order to do that, it has to be instructed to do or implement a function, and it uses instructions. Again, a computer only runs by processing instructions, and that is the same as the operating system. Operating system is just a set of programs that do specific things, such as manage the memory, manage the hardware, such as the keyboard, the monitor, so that when you type something, it goes up and displays on the screen. So we'll be looking at all the things it manages, all the different strategies it uses as it manages the computer, because there's various type of operating systems and computers. Some are just for one user. Some are for many users. So when you have an operating system dealing with many users, then it has to have some strategies of which user should be processed when. So there's different little programs that determine who gets processed when, or how much of that person's request gets processed. So that's what we'll be using our Java programming for. We'll be looking at the various strategies and algorithms that are used in the operating system. But it's a good foundation to have, because once you understand how a computer works through the use of an operating system, that means you can do anything you want with the computer, because you know now you have to go through the operating system. So if you understand how to do that, then anything else you want to do, if you want to take it farther, you know, into creating an application, then you know how to talk to the operating system. So this is a very important course to know and to learn well, So do take your time to learn this material well, so that then when you are carrying it further into other areas in information technology or in programming, you're already going to have that basic fundamental down of how to make that computer work for you and do what you want it to do. So, any questions so far on anything? Again, we will be having a full lecture on Wednesday. So make sure that you do read the material and the videos, so that I will explain further some of the topics. But when I start talking, it's nice if you read it before Wednesday, because then when I start talking about it, it will be familiar to you, and then you'll understand what I'm talking about. Then I can make it a little bit more sophisticated or complex. Good, I'm glad you like this subject. Again, really, any area of the computer technology you go into, this is one of the very basic, important ones that you need to know. So, again, do practice your Java, because this way you don't have to deal with Java, you can deal with what those operating systems are talking about, or what we're covering through the operating system concepts that we explore. And again, just start reading about it. What kind of computer do you have? Or what's your favorite kind of computer? Good. You have a, when you're working on a computer, you have a case, an actual case study right in front of you, which is nice in that start exploring the operating system on your laptop. Again, all of them do pretty much the same thing. They are all operating systems, have the basic fundamentals of managing your computer. So now that you have a laptop, you already have some operating system right in front of you that you can explore. And then when you look at those topics and learn about those topics in the course, you can then be able to say and look for it on your laptop to say, oh, now I know what my laptop is doing and how the operating system is helping it do it. This would be under systems. So look at your laptop and, get all the basic features of it. Or look at what is your system. These are all components we'll be talking about. Like how much memory do you have? What kind of storage, input, output devices do you have? Because everything on your computer that you have is being run by your operating system. So it'll give you a glimpse into those programs that are operating those features on your laptop. Okay, for the laptops, it's the Mac or, Mac operating system or Windows. Unless you have a specialty laptop. But those are basically two. So what do you have? Do you have an Apple or a Mac or a Windows? Okay, so we're going to get a look into Windows. Mac is also a good one. They vary. One thing about, if you want to go down historically as to how all this started, Windows, the operating system known as Windows, started out as DOS, disk operating system. And what happened was they were not proprietary. In other words, all manufacturers were able to create hardware and software for this operating system. And that's why you have so many types of computers that can run Windows. You have different companies. There are many companies that do the Windows laptop. You know, from HP, Gateway to Dell, Sony. And that's because when they first created it, they didn't make it proprietary. So anybody could create anything as long as they knew DOS was going to run it. Mac, on the other hand, is proprietary. In other words, that's why if you have an Apple or Mac, you only can buy the products from Apple for your Mac. They made it proprietary. In other words, you don't see other computers running the Mac operating system, only Apple computers. So we'll look at the difference between those two. But that is why there's more Windows than Mac. But Mac now are becoming, or Apple products are becoming popular as well. They're known to be better in your graphics and desktop publishing. And Windows is more in the business world because they took hold first, and all the businesses wanted to have a computer and knew that computers were important, and it really helped the office and the workplace. So that's why a lot of companies will automatically have Mac, or they may have a mix. But then, other than laptop, what other computers are there that you know of? Let's see if you know your history of computers. Okay, other than laptop, are there bigger computers, smaller computers? Right, mainframe, supercomputer, you are correct. So historically, you had these larger computers. It's not just until recently, or fairly recently, if you're talking about history, that we got the smaller and smaller computers, but before they were very large. I mean, some of the mainframes would take up a whole room. So they were very large. But with the advent of technology, the importance of computers, everybody worked to get them smaller and smaller. They worked to get them in everybody's home, you know, in every workplace. Before, the large mainframes were too expensive. You couldn't have a mainframe in your home. Supercomputers. Now, supercomputers are specialized computers in the sense that they are very powerful. I mean, NASA, you know, very large government or organizations will be using the supercomputers who need sophisticated, like genetic type of statistical processing or weather processing. And again, that's not something you'll find in a home. But our laptop computers are very sophisticated and can process faster than some of those first mainframes and supercomputers. As the technology became smaller, the processing became faster. Airports use supercomputers, exactly. And it has to be a very big organization to afford to even purchase a supercomputer. Because the hardware, you see the little hardware on your laptop, you have all those capabilities, but a supercomputer has them more and to a vast amount. Some companies you will find they still have their mainframes. They might still have what they did because the mainframes, if it's a company that's been around for a long time, they had a mainframe when they first started, and sometimes they have a lot of data on it or a lot of history on it, so they may keep it just to be able to, right, for servers, right, they can have it for servers, they can have it for data storage, sometimes tape storage. In the old days, you had a lot of tape. It's faster, just, I mean, it's easier just to use what's there already than to copy everything then to a new device, you know, or a new computer, because that takes time. So that's why we have networks that can access all these different types of computers. So this way you don't have to take the time for copying everything from that mainframe to some, you know, other newer computer. Just have your network be able to access it. Huge databases, exactly. So historically, you'll typically will have the mainframe supercomputer. Then there was a mini computer kind of in between, and then the desktop, and then now the laptop. And then after that, we're going into tablets, right, the micro, mini, micro, so main, mini, micro, super. And now you can get computerized, specialized computerized devices that are small. It could be, you know, a watch. You know, you have the tablets, the notebooks. But some right now we're at that stage where it's too small, it doesn't offer that much. Like how many of you have an iPad or a tablet? So you know you can't do everything on it. You find sometimes you could do some stuff on it. What is it you don't use your iPad for? Or what do you use it for? Right, there's limited usage because we're not there yet. You only can, it's small, but you only could put so much on that small device. But we're working on it. There's a lot of mobile device technology that's exploding right now. So that is a market right now that who knows where it's going to take us, because now there is competition to be able to have everything. You know, they're trying to take that supercomputer and put it into a small little device you can hold in your hand. So that's probably a goal, but we're not there yet, only because we only have so much space and can only put so much on it. And not only that, we'll be looking at, too, a lot of these hardware devices, they get hot. They generate a lot of heat because they are just electronic devices, or, you know, and the electronic devices do get heat and generate heat. So you can't, your iPad, if maybe you used it too much, you know, it'll get too hot and it'll overheat and shut down. So that's too why there's not as much processing on those smaller devices as the larger ones. Yeah, so that's typically, everybody uses their mobile devices for playing games, reading books, maybe surfing the internet. And then we'll look how that varies. Now again, depending on your device that you have, will determine the capabilities of your operating system. Because remember, it's the operating system that is making that device work. So that'll give you a clue too as to what kind of operating system it must be because of the device that is running. So we'll be learning in all those little distinctions, like single user, single tasking, multi-user, single tasking, multi-user, multitasking, parallel processing. That's another one. Again, depending on what you have on your computer will determine how sophisticated the operating system is. All of them do have basics because we all approach our devices similar. It all has input and output. It all has to interact with the user or some type of input device. So all operating share basics, so we'll learn about the basics that they all share, and then we'll look at how they specialize and what they specialize in and how do they specialize. The more sophisticated the operating system, the more strategies it must contain. For example, I mentioned all these single user, single tasking, multi-user, single task. Now when I talk about user, obviously it's how many users can use it at the same time. And when I talk about task, I mean how many programs the computer can process at one time. So single task means it only could run one program. Now you might think sometimes, well, I use my laptop, I could be typing something, I could have the internet open, and I can also be printing. Well, you think they're doing it at the same time, but the computer is really not doing it at the same time. What it's doing is just switching, and it's just switching very quickly, that you just don't notice that it's switching. But you do notice the more things you're doing at the same time on a computer, it slows it down. So it's not really multitasking in that sense, is that they're actually processing and working at the same time. The operating system is just smart enough to switch very quickly between them. So well, look, how can it do that? How can it not get confused? Maybe it's printing something and you're typing something and it's also playing music. How come it doesn't get confused and try to send the music to the printer? Well, that's where this program has, that's what we'll be looking at. What does it do so it doesn't get confused? So it doesn't by accident try to send music to your printer. And you know, we all know you can't print music in the sense from, you know, the sound. You can't print sound, in other words. So those are some fun aspects. And also, it's not magic. When you type on the keyboard and that appears on your screen, it's just not magic. There is actually some processing that's going on. That operating system is taking what you are pressing on the keyboard and then putting it in a special location in memory that's reserved to then be sent to the monitor. So a way these things are configured in your memory determines what the operating system does with it. So there's a lot of tables, there's a lot of patterns, there's a lot of specific areas where things are placed. Because remember, the operating system is not like a person. It's not smart like a person to look at something and say, oh, I know that sound, so it should go to the speakers. Oh, I know that's a picture, it should go to the monitor. It's still a machine that just reads patterns of bits and bytes. So we're going to look at what bits and bytes are because we have to take it to that level. Because the operating system is working just with signals. It makes sense out of these signals, but the computer only functions by where the signals are sent. Okay, so the operating system will send these signals in the wherever it should go to make sure then the job is done. But in order to know where to send the signal, it has to determine what you are telling it to do. So there is several levels of complicated instructions it goes through, but that's some of the things you'll be doing with your Java programming. You're going to simulate what it's like to find a signal and what to do with it, how to get a signal and determine, is it sound should go to the speaker, or is it something that should go to the printer? So that's some things that we'll be using through our Java programming. So it'll be kind of fun. Even though we're using Java, it'll be a way to simulate what goes on when the operating system gets these signals. What does it do? So we'll take a look at how this is handled. Again, some of it all runs the same. You know, everybody has keyboards, printers, monitors, and sound, and, you know, microphones. So some of it, you know, a lot of it works the same, but it's just knowing when you get that signal what to do with it. So any questions you have, what would you like to know about right now, as long as we're just in our office hour and just having question and answer? Are you following me okay when I'm talking? Or is it I mean, does it make sense to you? What I'm saying, I'm kind of bringing it down to a very, you know, way that maybe you can understand and relate to it. I'm not talking about bits and bytes and processes and, you know, computer chips. No, it is a computer chip. What is a microchip? Do you know what kind of microchip you have on your laptop? Is that a tough question? What is it? I know, I bet you know that all computers have them. So you know it's in your computer, right? Okay. So we have an Intel. Intel was one of the first for the IBM, or your PCs, as they call it, or your Windows. Intel was one of the first. And then also you may have an AMD. Now there's two kinds, if we want to go historically, there's two basic chips. We have a RISC chip and a CISC chip. That is why you have two different operating systems. The RISC chips are typically were the starting chips for the Apple computers, and the CISC chip is for the Windows. I'll bring it down currently to the Windows computer. Because it's a different processor, that's why the operating system is a little different. RISC stands for Reduced Instruction Set chip, and CISC is Complex Instruction Set. Now, we all know we have to give a computer instructions to process. With a RISC chip and a CISC chip, how they differ is the amount of instructions it has as a base to then send to the computer. So we will be looking at these chips because these chips determine, too, the type of operating system as well how the operating system functions. So it's pretty much the brain of the computer. It is the main piece of hardware that actually allows the electricity to flow through your computer and do something. So we'll be looking at those different chips. But in general, again, start getting to know your own laptop. You know, look at what is your microprocessor. Look at what your microprocessor is. How much RAM do you have? What are your input and output devices? And then what are your storage devices? I'm sorry, that's storage devices. So when you look at those components, that's what your operating system is actually making function. For devices, you know what is known as a device driver. Have you heard of what a device, do you know what a device driver is? Does anybody know what a device driver is? The little program that drives the device. So all your different hardware components have a device driver. That's why if you buy, like say you buy a component like a printer, it might come with a CD. Yes, it was actually the software program that's used to make that device work. Your operating system comes with some, but anytime if you add a new device to your computer, say you bought a new printer, that new printer will come down with a CD and it has the software to run that new printer. Or if you buy a new microphone, or a scanner, whatever you have on your computer. So you can add to your operating system. So whatever you have on your computer, the operating system that comes with it can be added to it. You can add to it, you can customize it, you can personalize it. One of some examples of personalizing is the screensaver. How many of you have a screensaver? Do you have a cool screensaver? Or do you have cool pictures when you first start up your computer? How many of you have pictures? Okay, so there you go. You're a little bit of a systems programmer. When you use the operating system to do things or customize the operating system, you're known as a systems programmer. When you do something like type out a Word document or create an Excel spreadsheet or create a PowerPoint presentation, you are known as an applications programmer. So depending on what it is you're programming will determine what kind of programming or programmer you are. What are some areas are you going for? What is your favorite area to learn about in computers? What do you want to do in the workplace? What do you want to work at? So you want to do programming. Good. Is that for all of you? But again, you can do programming, but you can be a systems programmer or you could be an applications programmer. Working with databases, that would be applications programming because a database is an application. In other words, system programmer is someone who does programs or works with the system, the computer system, to help it run better. Applications programmer creates things that can be applied to the world, something the world will use, and that's a database. All companies have a database. Systems programmer, so you're going to learn how to set up the system so that the devices work properly. You may have to customize it so programs are run properly, but also may have a priority. There are some areas where the computer might be processing a program, but all of a sudden something important comes in and it has to switch to this important job. So the systems programmer will set it up so the operating system knows then when there's this emergency program coming in, everything has to now stop, do the emergency program, but then when it's done with the emergency program, be able to go back and then resume where it left off. So those are some items with the systems programming. So it all depends. If you like to work with hardware, then systems programming is right up your alley. Again, when you systems programming, it's good to look at then all the different hardware components. How many of you opened up your computer? Opening up your computer and look at the components. But we will look in this course. We'll look at the actual hardware. How is it placed inside that machine? And also tools that you have to do. Just like I mentioned, the screensaver or having pictures, those are systems, utilities. But some other system utilities are like antivirus programs, network programs, routine maintenance programs. There is routine maintenance you should perform on your computer. If you haven't, well, we'll talk a little bit about it that you should be doing. There's something called defragmentation, disk cleanup, and those are some things that you should do on a routine basis to keep your computer running smoothly. But then the database, now there's a lot of, in the business world, there's a lot of programming that needs to be done also. You need to create applications to work with databases or load in databases. So that's a good area as well. There's a lot of areas that you can specialize in. But one thing is, you all need to know about the computer no matter what area you go into. You all need to know about operating systems no matter what area you go into, because you will have to deal with it in one way or another. A systems program, you'll deal with it more and in depth, but applications programming, you still have to be able to do that too, just for the fact that you have to know what computer your software will run on. If you have an Apple and if you went to a Windows, there are different programs. Not all programs run on every type of computer. We'll also be looking at Linux. How many of you know Linux, or have you heard of it? Linux is another operating system. We'll be looking at Linux. So we'll be looking at some of the major operating systems that are out there and how they differ from each other and what each one is better at. They all have kind of their special features that make them just a little bit better in there. Right, so Linux is very popular, especially in the internet world and in the programming world, because they say Linux is more secure and it's more customizable. You can customize it, and it can run on a variety of different machines and devices. So a lot of programmers like Linux because they can do a lot of programming for it and customize how it works. Windows, you can't change too much. Windows is what it is, and the same thing with the Apple. You kind of have to use it the way it is, and you can't really change it too much. But Linux, you can. So again, all depending what you're doing. If you're just using it, you know, to view this class, you don't have to customize any operating system. So we'll be looking at those items. And again, you'll have fun in simulating the things operating systems do with your Java programming. So don't hesitate. I do want to let you know, email me or ask your questions in the discussion forum. I hope you do post a lot in the discussion. This is the way you can reach out to each other. And also it's a good area to offer support and encouragement to each other, because you're all in this together. And this way you can help each other and collaborate together. And I will always be bringing in different topics and resources and links to show you some cool stuff out there maybe you would like and know about, because computer technology changes so much. Every day there's something new. So this is a good way to share with each other something new that you found and want to know about. So bring it into the discussion forum so we can always discuss more about it. But again, the first thing is go start reading the material, read your textbook, look at the videos, and then start looking at your own computer. You got one in front of you. Look at your own computer. Know what you got on your computer. Look at the hardware you have. And look at your operating system. What version is your operating system? A lot of you said Windows, but what version of Windows? There's a lot of different versions of Windows. What is the latest version of Windows out there? Seven is, but actually there is already an 8. Oh, you have 7. So a lot of you have Windows 7. For those of you who have Windows, okay, that's good to know. Then we'll know where we're at. But there is the Windows 8 already. You can learn about the 7. But again, we'll be using Java to simulate some of this. A lot of this will be done in simulation form. So it's just a matter of making sure that you can get into the online classroom. You've all taken, hopefully, online classes, so you know how to work through Blackboard. You know how to view the videos. And then when we're going to be doing anything with the programming, again, do work with each other on it in the classroom. Bring your questions to the discussion forum or email me as well. But this way, if you bring it into the classroom, then you know for sure, not only I'm going to see it, but also your classmates. And maybe they already completed it, so they already have an idea. Or maybe they have the same problem, and they already fixed it. So it's a good way then to work with each other as well as me. So we will all work together like one big happy family in learning this. And do know that you may be reading about it in the textbook, but if you don't understand it, don't think you're never going to get it. That's only because maybe you just don't understand that the textbook author maybe is just writing it in a way it doesn't make sense to you. then go ahead on the internet and look for information that maybe explains it in a better way for you to understand. Okay, there's a lot of resources out there. So you're not stuck with just your textbook. Go on the internet, look for more videos. If you really want to know it, then look for what's out there that tells you about it. And each textbook might show you something that is a little better or a little bit more. So feel free. And also, if you do find another internet site that offers good information, bring it to the discussion forum and share it with your classmates. That'll make you feel good, because you found this cool site for everybody then to get more help with understanding the material. So we're just going to be starting out in week 1. We're going to be going over the basics of what operating systems are. One of the videos or the PowerPoint presentation kind of does an overview of the entire book, but don't get overwhelmed. Remember, when it talks about the entire book, that means it's going to be over the whole course, not just in week 1. So we will be looking at it. It just, again, gets you familiar with the terminology, kind of gets you start hearing and seeing what it is we'll be discussing. And then as the weeks go on, we'll get it in more depth. But start out small to understand. Sometimes when people start talking about hardware and all these inside configurations, since you can't see it, sometimes it's hard to understand it. Because what you see is just how you use your computer. But if you know exactly what's going on inside, it's hard to understand it if you don't actually see it going on. But that is, though, what you'll have to do, make that connection. So that when you press that key, you know your key on the keyboard, it's all signals. The computer works on signals, and it has a little clock that every time that clock ticks, the signal goes to the next level. That's just basically how the machinery works. Now, the operating system then listens to these signals, determines what to do, and when the clock ticks, pushes it to the next level, or kind of opens up the gate to that next level, so that it then continues on and processing instructions. And it works very quickly. Like I mentioned before, you might have a single user, single task computer, but you see that you can do a lot of tasks at the same time. But it's not truly doing those jobs at the same time, it's just switching very quickly between them. So it might appear that you're printing and listening to music and typing all at the same time, but you're really not. It's just that fast. So we'll be looking at these signals. How do we take these signals and make sense out of them so that the operating system can then put them into certain patterns, give them the instructions then to follow so that you get your desired result. So we'll be looking at that. And some of the strategies, how does it do it? It's complicated. It's only a signal. How can it distinguish one signal from another signal? It's just a signal. So we'll look at how the operating system makes sense out of the signal. Some of it is easy. If you know and you send a signal to the printer, then you know, well, that means something should be printed. You know, some of it makes sense. It depends where you send the signal. But sometimes the signals can involve more things, such as a signal that is maybe just a piece of data. It could be, you know, maybe you're adding two numbers and then you have a result. And that result is just a series of signals. So we're going to look at these series of signals and try to make sense out of them. That's where we translate the signal into a bit. A bit is either a signal or no signal. So I don't know if you're familiar with bits, but bits are ones and zeros, and they represent signal or no signal. So that's how we take those signals, make sense out of them. We convert them to ones and zeros, and then we even take that farther and take groups of 8 zeros and ones and call that a pattern. and then we assign the pattern to different things. So then the computer will look at a series of zeros and ones or a series of signals and say, aha, these 8 zeros and ones mean it is a number. Say the number 5. So the computer works with a lot of patterns of zeros and ones, and depending on the pattern will determine what it is and what the operating system is going to do with it. And that's pretty much the data that you're going to get for your Java. When you're writing your Java programs, you're going to get these series of ones and zeros, which represent your signals of on or off, and then you're going to determine by what pattern it is what your Java program is going to do with it. And then when it needs to send information back, it's got to send back these series of zeros and ones. So that's basically how we tie our world to the electronic world of the computer. It's these series of ones and zeros. So I know that several of you are leaving. I don't know. I am here till 9. So I know I just kind of giving you an overview, little bits of it here and there. I hope you're as excited about the course as I am, because it will be fun. We will learn a lot of good information. And again, I'm going to leave you with this. First of all, do the week one. Do everything early. Always look at your assignments early, so if you have questions, you can get them answered before you have to submit it for grading. Use the discussion forum to collaborate with your classmates. Also for me, I am very often in the discussion forum, so I will respond to you. You can email me as well. But get your questions answered right away so that you don't just keep building up confusion. And if it doesn't make sense to you, right, what you're reading or what you're seeing on the video, go to the internet. Type it in and see if you can find a better picture that makes more sense to you, or find a better